All right, you are welcome to class. Let us look at this question together. This question is under machine. The question says, a machine whose efficiency is 75% is used to lift a load of 1000 Newton. Calculate the effort put into the machine if it has a velocity ratio of 4. A machine whose efficiency is 75% is used to lift a load of 1000 Newton. Calculate the effort put into the machine if it has a velocity ratio of 4. Now, here we are to calculate the effort put into the machine. And before we can calculate the effort put into the machine, we must have gotten our mechanical advantage before we calculate that. So how do we get that? How do we arrive at that? First thing, we are going to list out or bring out our parameters excuse me, before we continue. So our efficiency, the efficiency of the machine is 75%, or let me say the efficiency of the machine is 75%. Now, let me write it in full so that you don't get confused. Efficiency is equal to 75%. All right. So we're given load to be 1000 Newton. And another thing we're given is the velocity ratio. We're given the velocity ratio. We're given the velocity ratio to be 4. All right. So how do we calculate our mechanical advantage using these parameters? Now, efficiency of a machine is equal to mechanical advantage over velocity ratio multiplied by 100%. So this is the formula to calculate efficiency, all right, of a machine. But we've been given efficiency of a machine, which is 75%. We want to calculate mechanical advantage so that we can use that mechanical advantage to calculate the effort put into the machine. All right. So how do we go about that? Since we have been given velocity ratio to be 4, efficiency of the machine to be 75%, we just slot in everything. So you have 75 is equal to MA over 4, then multiply by 100. All right. So we are going to make mechanical advantage the subject of the formula. How do we go about that? You cross multiply. When you cross multiply, you are going to have MA times 100. Notice there's an imaginary one here. MA times 100 times 1 will give us this, is equal to 75 times 4. 75 times 4 will give us 300. Give us 300. So we can now make mechanical advantage the subject formula. So how do we go about that? You just divide through by 100. So you have 3 over 100. So this one cancel out. So we are going to be left with mechanical advantage on the left hand side. I'm going to be left with mechanical advantage on the left hand side, which is equal to mechanical advantage is equal to, let us divide this one. Let's divide this one. So this one, 0 cancels 0, this 0 cancels 0. So we are going to be left with 3. So our mechanical advantage is 3. So we can use this mechanical advantage to calculate our effort by using this formula. Load over efforts because if you look at it, the load was given. The load is 1000 Newton. So we just substitute everything we have here. So you have mechanical advantage to be 3 is equal to load to be 1000 over the effort. Okay, so we make effort the subject of the formula. All right, so when we divide, we cross multiply. There's an imaginary one here. 1000 times 1, you have 1000. 3 times effort, you have 3 efforts. Then after that, you can now divide both sides by 3. Divide both sides by 3 so that you can be left with effort on the right hand side or on the left hand side, as the case may be. All right, so you have this over 3 is equal to 3 effort. That is 3 times effort. This means 3 times effort over 3. So 3 cancel out 3. So we are going to be left with efforts on the left hand side. So you have 1000 over 3 is equal to effort, and this is what you are looking for. So we can simply say effort is equal to 1000 over 3. So 1000 over 3 will give us 333.333333. So effort is equal to 333.33. So Newton. So that is that about that. So if you have any question concerning this, you can just put in the comment section so that we can look at it together. And if you have any other question, you can drop in the comment section so that I can factor that in my subsequent videos. All right.